Muy buenas tardes.
Good afternoon. Welcome, all of you, to our third meeting on research with the gender dimension, organized by ADItech and sponsored by the government of Navarra. Before we start, just a few technical announcements. You can listen to the speaker both in English and in Spanish. If you want to select the language channel, you will see an interface at the bottom of the screen with two buttons, and you can choose your language, English or Spanish, and you may swap at any time throughout the talk. Recommendation number 2, questions and answers. The question round will follow Gina's talk, and if you want to ask questions, use the box at the bottom of the screen, type in your questions, and we will select a few of those questions that will be passed on to Gina. Now, I would like to give you a context to our online free of charge webinar. A year ago, sponsored by the government of Navarra, our project started with the aim of contributing to the Navarran Innovation System, which is intended to take into account sex and gender variables in research and development projects developed in Navarra. Of course, not all projects will have to integrate such variables, but it is always pertinent to ask the question with a view to contributing to science excellence as prescribed or recommended by the European Union, the Spanish Act on Science and Technology, and our Regional Act on Science and Technology. The project has been supported and sponsored by the Equal Opportunities Department of the State University of Navarra, and of course the Navarra Innovation System, which is known as SINAI, an acronym. It consists of research centers and universities in the region. ADItech is the coordinator of the innovation system. We have 4 major goals: to encourage partnerships, excellence, and internationalization in the system, and to get society to know about our innovation system. As coordinators, we are to promote and facilitate the inclusion of the gender variable into the contents of research and development projects developed in Navarra in different areas such as mechatronics, automation, food chain, health, of course, renewable energies and resources, creative and digital industries, and tourism. Today's talk is a third lecture in a project, research with a gender dimension, and it is framed within the SINAI framework. We are honored in ADItech to have a very well-known speaker today, Gina Rippon, a high-statured pioneering researcher in cognitive neuroscience and emeritus professor in Aston University in the UK. She's also the author of The Gendered Brain, a book. She's also an honorary member of the British Science and Innovation. She received this award for her public dissemination of science. Without any further ado, thank you, Gina. The floor is yours.
First of all, learn to unmute. Thank you very much indeed, Maruja. And welcome everybody to this seminar. I hope you've all got good access to either or both languages, and I hope that you can see me. Thank you very much for inviting me. I'd love to have been with you in person, and maybe in the future that will be possible. So without further ado, I will move on to, hopefully, to my presentation. And I shall switch it on. Right. Make sure that we've got. Right. For some reason it. Excuse me, I'm just trying to get it to run from the beginning. I don't know why it's not working in presentation mode. Oh, here we are. Right. Okay. Apologies for that. So The question I've been asked to talk to you about this afternoon is your brain female or male, and why this question matters? And I think probably the second part of the title is the more important, because it's really to understand the fact that we live in a world of gender gaps. We live in a world where in science, in politics, in business, technology, finance, there's clear evidence of gender gaps, and closing these gaps matters. We know that increased diversity brings about better performance. We know that gender gaps actually signal the fact that there are large numbers of people who are not entering into these key areas of human society, science, etc. So it's a waste of human capital. So we need to understand where those gaps come from. I talked about gender gaps, but one of the key issues, which will be part of a thread which will run through the talk I'm giving, is the difference between sex and gender. And that is important to remember what we're talking about. I know that certainly in sort of mainstream science where relevant, there's been a call, which is linked to funding, to incorporate sex as a biological variable into research design. And that clearly is important. And I will indicate at various stages in the next 40 minutes or so that I'm not a sex difference denier. A lot of what I'm saying or will say will be about the fact that the differences that we've long held between the brains of men and the brains of females are not as well established as we thought. But I think there are, sex differences in the brain, and they may well influence some of the research that we're doing. But the other aspect we need to think about is gender, and I will say a bit more about that particular difference, because we know that gendered behaviour, wherever it comes from, gendered expectations associated with stereotypes, gender perspectives in research, and gender bias in all fields, in science, in politics, in business, in government, is really important to try and find out where the differences come from, how important they are, whether or not we should say those are so fundamental that we should embrace these differences and make best use of them, or whether or not we should say, are they in any way limiting individuals, human beings, limiting their potential? So what I'm going to be talking about is new insights into how our brains interact with our world, which is really looking at issues of gender, and whether or not that will help us understand initiatives which are going to help us tackle the gender gap, because we do need to know where these come from and the factors behind them. So that is the key issue. Moving on, hopefully, to the next slide. That's just to present my credentials, if you like. As Maruha mentioned, I'm a cognitive neuroscientist. I work in the Aston Brain Centre, and I spend my days, although I haven't this year, I have to say, using various brain imaging techniques, in fact, mainly to look at developmental disorders such as autism. And my key issue, particularly with respect to autism, because it's a hugely variable condition, if you like to use that term, it's to understand individual differences in the brain. So my research is really trying to say, can we find differences in individual brains? Can we characterize them in a particular way? How do brains get to be different? Where do those differences come from? And again, with respect to the significance of what we talk about this afternoon, what do those differences mean for the owners of those brains? So the book, as was mentioned, is called The Gendered Brain. And of course, the focus is very much on the vexed or interesting, depending on what side of the argument you're on, issue of whether the brains of men are different from the brains of women. This was supposedly one of the most well-established differences. So I spent a long time going through the research, both into brain research, neuroscience, but also behavior, and saying, what kind of research has been done to answer this question? How good is this research? Really with an idea to taking the principles and applying them to understanding individual differences in developmental disorders, for example. But what I found was that, in fact, what appeared or has claimed, alleged to be a well-established difference wasn't really that well-established. And it did draw me into understanding some of the ways in which science can be directed, or if not diverted, by long-held and preconceived beliefs. So again, going on to the next slide, this is just a history slide to say the question, do you have a female or a male brain, or are male brains different from female brains, didn't used to be a question. It was a given. Of course, male brains were different from female brains. Because back in the end of the 18th, beginning of the 19th century, when brain science was emerging as a science and it was beginning to be understood that understanding the brain was going to understand help us understand human behavior. The scientists at the time were very well established in terms of understanding a status quo, and said, well, let's have a look at society. As brain scientists, we're going to help the world understand itself, the world understand human behavior, the world understand who could do what or who couldn't do what. And so they looked at the status quo and they said they could see that males and females were very different. They had very different statuses in society because they did. Women had an inferior status in society because they did. And they said, therefore, women must have inferior brains. And so you get these wonderful quotes from one particular neuroscientist, Gustave Le Bon. Women represent the most inferior forms of human evolution and are closer to children and savages than to an adult civilized man. So, you know, hardly the objective view of a scientist interested in finding out particular differences, bringing a particular bias, I would suggest. And later on, only just less than 100 years later, we get other statements from voices such as psychologists. We must start with the realization that as much as women want to be scientists or engineers, they want first and foremost to be womanly companions of men and to be good mothers. So there's a clear idea that there is a different set of behaviors early on, quite clearly described as inferior, and a bit later on the term complementarity was used. So yes, there was a different brain and that gave you different kind of skills. But I draw your attention to this because it does indicate that right at the beginning of this search for differences in the brain, not even whether or not they existed, it was taken as a given that they existed. There was bias evidence. And at this time, it's also worth remembering that we didn't have access to an intact living human brain inside an intact living human. We could look at what happened at autopsies, we could look at dead brains, we could look at disease brains, we could look at what happened when people had certain kinds of injuries and draw conclusions, but we couldn't actually look at brain. But that didn't stop the scientists at the time. They put a huge amount of effort in devising certain sorts of metrics which would allow them to infer the kind of brain that they were actually looking at. So very early on, there was an idea that you could fill an empty skull with bird seed or buckshot, and then you could weigh that seed or buckshot, and that would tell you how big the brain had been, that was inside the skull. And there was big excitement early on because it turned out that on average, and that's a very important phrase we'll come back to, men's brains were 5 ounces heavier than women's. So immediately, classic size matters conclusion. Big brains are better than little brains. Men have got bigger brains than women, therefore that's why they're superior. But then that metric had to be adjusted because somebody said it can't just be size, because creatures like sperm whales and elephants have got bigger brains than humans, and they're not generally renowned for being more intelligent than the average human male. So then there was various ratios devised and all sorts of other techniques, such as phrenology, feeling, the head of your scalp, or this wonderful technique, craniology, which took intricately detailed measures of various characteristics of the skull and the face and the angle of the earlobe to the chin, etc. Some papers had up to 500 different measures, and that supposedly told you what kind of brain there was inside that skull. But it's important to note, and that's again with the bias I've already drawn your attention to, that there was again an agenda behind these metrics, because the idea was that whatever scale, hierarchical scale, was generated by using these measures, at the top of that scale had to be white, because it also intersected with the sort of race question. Upper class came into it too, educated males. And then further down, you got women and children. A bit further down, you got other classes. And a bit further down, you got other races. And if a metric or the use of a particular metric didn't come up with that answer, then the metric was discarded. So there's nothing wrong with the preconceived answer you were investigating, there must be something wrong with the metric if you didn't come up with that answer. Now, I'm not saying that the way in which research is governed today is in any way that extreme, but it's worth bearing in mind that this is a kind of science where there are preconceptions, which, as we shall see, do determine the kind of research that's done. But right from the beginning, the idea was that this was very much hunt the differences. It wasn't a question about whether there were differences, it was really trying to find them. Okay, so moving on. What these early researchers then came up with was a particular chain of argument, which I've characterized here, which was really, if you like, how sex got to be gender. And the idea was that whatever it was that determined the differences between male and female anatomy, bearing in mind that at that stage we didn't actually know about the genetics, but clearly it was clear to scientists that male and female had different anatomies. And that then caused, and that's an important phrase too, them to have different brains. So if you had a female anatomy, you had a female brain, ditto male. What then happened was that having that kind of brain, again, causally, gave you a different portfolio of skills. The classic idea was that if you had a in quotes, lady brain, you were very good at empathy and emotion, understanding emotions, but you were rubbish at reading maps. And then there was a whole list of characteristics that psychologists came up with, which described female characteristics. And similarly, if you had a manly brain, you were very good at sort of scientific problems, very good at spatial thinking, brilliant at reading maps, but rubbish at understanding emotions or listening. And again, a long go-to list of characteristics, which determined your kind of characteristic patterns of behavior. And that particular portfolio of skills and temperaments and personality then again caused you to have different roles in society. If you were very good at emotion, you were very good at maternal instinct, for example, that meant you were good at caring and nursery nursing. Whereas if you had a manly brain, then clearly you had the right kind of skills to make you a great scientist, a great leader, winner of Nobel Prize, etc. Effectively what they were saying, and it's important to remember that early on, there wasn't a term for gender. It was assumed that sex, the biological characteristic, determined each of these stages. So yes, there was a male and female brain. Yes, that meant you had male and female or masculine and feminine characteristics. And yes, that meant that you had different roles in society. And it's important to remember that this idea is that, again, we're looking at the basic fundamental rule that sex determined each of these levels. And as I say, there wasn't initially a term for gender. If we then move on, this is again a way of characterizing. Okay, sorry, I seem to have got something which is an additional phrase going on. I'll get rid of that. Okay, so somehow I've picked up a slide. What we're really talking about here is that how do female brains get to be different from male brains? Biology is destiny, it's fixed and it's inevitable and it's invariant. I'm just wondering, something has happened that there's a separate script going on. So hopefully you can't hear it and it's not distracting you too much. What we really are looking at here is an argument which is saying that male brains arrive in the world, determined characteristics, and they will grow to a particular fixed endpoint, which will determine them that they will have particular skills. Similarly, we have female brains which arrive in the world slightly differently. They will not acquire the necessary skills to determine that they will be able to be educated, to be scientists, etc. And they will arrive again at a fixed endpoint, which gives them a different kind of brain, which affords them different kind of skills. So we have a book called The Female Brain, which I'll come back to possibly, also a book called The Male Brain. So there was a clear idea that there were differences here. And the kind of book that you got associated with this is a book called The Essential Difference, which is not the only book bearing this particular belief, but something that I think we need to think about. And that is, this book was called The Essential Difference. And this was the idea that there was some kind of biological essence which determined males were different from females. And this book is called The Female Brain is Hardwired for Empathy. The Male Brain is Hardwired for Understanding Systems. So it's important to realize that this particular book is talking about a particular kind of brain, the female brain. Hardwired is a very important phrase. And it's also the case that we can understand that the male brain is hardwired for understanding systems. So each of those are saying, buying into this essential argument. Okay, so I think what we need to say at this point is, this is the argument, which is that sex is the determining factor of any gender gaps, because sex has determined that characteristics of these brains and these brains are underpinning what we're actually looking at. Now I'm going to move on to the next slide, which will hopefully switch off that script. Apologies for that. But that was really to say that we're looking at a binary argument, which suggests that female brains are different from male brains. But remember, at this stage, we weren't able to look at brains. So we had these kind of clear-cut beliefs about the differences between male and female brains, which had not been tried and tested. It wasn't really until the end of the 20th century, in the 1990s, that we were able to look at the kind of images that I can produce in my particular lab, where I'm using different kinds of techniques and using different kind of tasks to see what's happening in individuals' brains. These images are wonderful. They have been described as seductive. They're very compelling. They do give a slightly misleading belief. That is that we have a kind of real-time window into what's actually going on in the brain. There's a long chain of statistical decisions, of image manipulation, of mathematical formulae behind producing these images, not in any way fraudulent, but it means that this isn't exactly, we can't look at this brain, and it would lead you to say, oh, look, that part of the brain is lighting up when somebody's looking at a face, that part of the brain is lighting up when somebody's trying to remember a particular list of words, for example. So people found these very compelling, but they were slightly misleading. The other issue is that they lend themselves to the idea that if you're looking for differences, these images are actually images of differences. They're not images of raw activity in the human brain. They are images of differences between the human brain at rest and the human brain undergoing a particular kind of task, carrying out a particular kind of task. There may be differences between different groups. And this particular production of images lent itself wonderfully to what I've called the Hunt the Difference agenda, which is where if you believe that there is a difference between two groups, it's easy enough, particularly if they're males and females, to take two groups of participants, male and female, put them in the scanner, give them different kinds of tasks, or the same task, and then see what the differences between their brains are. It should be also pointed out that all of these images are actually manipulated in a way that you magnify any of the differences you find, because the differences are actually very, very tiny, particularly on average. Because again, it's important to remember that we're looking not at absolute differences, all men are like this and all women are like that, although the narrative associated with this story may well lead you to believe that. We're looking at overlapping sets of data from males and females with tiny differences between the averages. And so therefore these have to be magnified. So again, the kind of impression you get from early brain imaging is that, gosh, there are really big differences between male and females, because look at the difference here, for example. But how did science actually do with searching for these differences? And again, it's important to realize that if you actually look at a research canon, if you're perhaps not a neuroscientist, but somebody who's interested in understanding the differences between male and female brains, you might go to a research database and you might type in sex differences in the brain, and you will get thousands of papers saying sex differences in the adult human brain. For example, one I picked here, evidence from 5,000 UK biobank participants. So you then get the impression that, well, there's so many papers reporting differences that clearly there are differences. And really what we're looking for is some nice catalogue, some nice map that we can look at. We'll say this is what the human male brain looks like, this is what the human female brain looks like. But when you start to look at these papers, you'll find, yes, absolutely, they have found some differences with quite genuine techniques using well-established tasks, for example. But another set of papers, and they might, and this paper, for example, reports differences in a structure called the amygdala, another one called the hippocampus. Another set of papers will again report differences, but they will not report differences in the hippocampus. They will say there are no differences there, but there are differences in, for example, the thickness of the cortex or the particular cell count in the cerebellum, for example. And eventually you start to realize there are huge numbers of papers reporting differences, but they're not reporting the same differences. And there are other papers coming out saying, doing meta-analyses, looking at lots and lots of different papers, comparing the effect size, the results that have been found, and saying, well, actually what we're looking at is the fact that there is no consistent finding. Yes, each lab has reported a particular finding, but it's not the same finding in another lab. That's not to say that either of the labs are wrong. It's ignored the fact that there's a huge amount of variability in the characteristics of everybody's brains. Every brain is different from every other brain, and that's an important part to remember, but not in terms of comparing them as to whether they're male or female. So there is no consistent difference, and I think that's important to bear in mind, because you get the impression that brain scientists have caught up with this. And it's very often the case, in fact, in terms of the kind of public interest, quite understandably, in the relationship between people's brains and their behavior. If there's a kind of whiff of a neuroscience finding in a neuroscience journal somewhere, very often the popular press will pick it up, and you'll get big headline, at last the truth, as though we scientists have caught up at last, proof at last, women's brains are different from men's brains, and then there's a list of particular findings. So it's important to remember that we are being misled by whether or not this story about male and female brains still holds true, even though there's lots of very good research which seems to be finding some kind of differences. So we're not there yet. There is another issue, which I call the Iceberg Problem, and that is the fact scientists will be familiar. It's another, sometimes called the file drawer problem. If you set out with a particular hypothesis, the hunt the difference agenda, that male brains are different from female brains in a particular characteristic, and you carry out your research, hopefully well funded, you do wonderful techniques, etc., and you don't find a difference, then you might not submit it for publication, because your hypothesis was there would be a difference and you haven't found one. So maybe there was something wrong, maybe you need to replicate the study, you need to use a more discriminatory test, for example. So when there isn't a difference, it doesn't get reported. Or you may submit the paper and the reviewers might say, well, you must have got something wrong, because we know that men's and women's brains are different and you haven't found a difference, therefore we're not going to publish it. So just as much as you've got this tip of the iceberg publication record, which in itself is a bit misleading because it's not consistent, you've also got a huge amount of data here where no differences have been found. And that in itself might be very interesting. It might mean that actually we're asking the wrong question. If we do all these comparisons and come up with this amount of lack of differences, maybe we should start rethinking the filter we're using. Maybe there's a better way characterizing the brain. So that's important to bear in mind. So the idea that there is such a thing as the male brain and the female brain, certainly in the last 20 years or so, has been heavily criticized. And it has come up with a suggestion that there is no such thing as a brain, typical male brain or a typical female brain. I can't, as a brain imager, look at 2-4 different scans and say that one's from a male, that one's from a female. I can't take anybody into my lab, a male or a female, and say, I know what this person's brain is going to look like. And I think that's really important. We don't have a characteristically typical brain that we can say that's male and that's female. And the reason this is important, I'll come back to later, because this isn't just a question of anatomy. If you remember back to the chain of argument that I was talking about, the assumption is that if you've got this kind of brain, these are the kind of skills you have, this gives you this kind of role in society. Now, if there's something wrong with the beginning of that chain of argument, then the rest of it needs challenging. So understanding whether there is a male or a female brain is important. And more recently, using the increasingly detailed techniques of different kind of brain imaging techniques, Daphne Joel and her team in Tel Aviv have come up with the idea that if you looked at what they did, they looked at over 1,000 different brains, and they looked at over 100 different structures and pathways within the brain and said, let's have a look at each of these 1,400 brains and see for each of these characteristics which are mainly male and which are mainly female. So there were structures which were characteristically larger in males or characteristically larger in females, not absolute as we've already seen. But when they actually looked at these 1,400 brains, what they came up with was the fact that I think it was something like less than 6% of the brains, no single brain had all male characteristics. Less than 6% had predominantly male characteristics. And all of the majority of the brains they looked at had a kind of mosaic of different parts of structures which had been claimed as more likely to be found in females, or structures which had been more likely to be found in males, but in the same brain. So we're moving away from this idea, anyway, a binary idea, which is something we'll come back to, but the idea that actually we should be looking at brains in a completely different way. So I think that's quite important. And it's also important to bear in mind that we're looking at different ways in which scientists describe their research. So sometimes if you do find a difference, you'll find scientists describing them as profound or fundamental, and that's something that we need to be quite careful of. So moving on swiftly, hopefully, has 21st century neuroscience then got anything useful to say to this question? Are we just picking away and saying, well, I don't actually think there are these kind of differences? Should we then go back and say, is there a different way of asking this question? Is there a different way of understanding how people do get to behave differently? There are gender gaps. And this is where my particular model is what I've called the 3 Ps, because it's a helpful way of remembering it, hopefully. But it's the fact that each of these characteristics of how the brain works is something which has emerged in the 21st century and actually is very pertinent to understanding differences in individual brains, but as we'll see shortly, differences between males and females. 3 characteristics. Our brains are like predictive texters. We used to think brains received information and that they were brilliant at processing that information, but they were receptive and they responded when the information arrived. What we now realize on closer examination of brain activity, particular patterns of different frequencies of brain signals, is that our brains are actually more like gambling machines. They're more like predicting what's going to happen in the future. They are, if you like, the ultimate stereotypers. They're gathering together past experience, giving us a quick shortcut and saying you don't need to pay much attention to that sound or that light or that particular type of behavior, because this is what it means, this is what normally happens. And you might think that's a bit alarming, but actually the brain is generally very good at it. It's very good at checking out what's going on in the outside world and driving our behavior appropriately. And if there's any mistake and something went wrong, or the expected sight didn't emerge, or then we get things like visual illusions, for example. But it sends back an error message saying, no, I thought this was, I was establishing a rule for you, but that rule isn't quite right, so I'm going to readjust the rule. The other thing we now know in the last 30 years or so, that our brains are plastic. If you remember right back from that rather confusing slide I was showing with the second narrative going alongside, the idea was that our brains reached a fixed developmental endpoint, possibly towards the end of our teens. But once our brains had become mature, that's how they stayed. They didn't change in any way. There was a kind of a message mantra that we are born with our adult number of brain cells, and the only thing that happens is that we'll lose them gradually, but eventually we'll reach the end of our lives, and disease and old age and degeneration, etc., will take over, and they'll start to disappear, and our faculties with them. But we now know that all the experiences we have throughout our lives will change our brains in quite profound ways. They will change the structure and the function, but they will also change the skill, if you like, to which they are attached. So experiences are very important. And this is characterized here by a well-known set of studies looking at London taxi drivers who have to acquire the knowledge in order to be a taxi driver. And this actually requires you to memorize the 20,000 routes, I think it is, within 6 miles of Charing Cross, to the extent that anybody could get in your cab anywhere in London and say they wanted to go anywhere else. You could instantly take them without using a sat nav, and also remembering, whether or not there were demonstrations or traffic jams, etc. So an amazing feat of visuospatial memory. Takes 3 or 4 years on average, sometimes longer. What the researchers did was they followed up these taxi drivers before they acquired the knowledge and got some brain scans. Once they'd acquired the knowledge and they were driving their taxi cabs around, doing the brain imaging while they were driving the taxi cab. But interestingly, they also looked at them after they retired, and they found the particular part of the brain associated very much with visuospatial processing and memory changed dramatically in those who acquired the knowledge. But interestingly, those changes disappeared once they stopped being taxi drivers. So this was a nice measure of the fact that our brains do respond to experiences. They wax and they wane depending on the experiences we have. Importantly, of course, it also means that if you haven't had those experiences, then your brain won't change in what might have been quite a useful way. We'll come back to that. The final P is the fact that our brains are permeable, that yes, they are making rules up or predicting what's going to happen. They change according to the experiences, but they're also aware of the social context of tasks they're presented with. In social psychology, this is known as a stereotype threat. And this is the idea that if you belong to a particular group who has a stereotype associated with them, that they're not very good at a particular kind of task, a belief, and you're doing that task and somebody reminds you that you're a female and this is a maths task and females generally find them quite hard, but never mind, do your best. Surprise, surprise, that will change your behavior and you'll make more errors. But we also know that that's reflected at the brain level. So if you give a group of individuals a task and say you're generally quite good at this task, let's see what happens, then you will find perhaps the appropriate areas of the brain activated and they will do well. Or you'll say, this is a task that people like you are not generally very good at, but do your best. You'll find that A, there's more errors made, but also that the brain is processing the information differently, monitoring much more closely the errors and not activating the useful parts of the brain associated with solving that problem. So your brains are also responsive to a social situation. So each of these means that there's much more interaction with the outside world than we ever realized with our essentialist model, with the idea that the brain was a kind of fixed vacuum-packed organ, which was genotypically determined and grew bigger inside you and carried you through life. It turns out that your brain is much more responsive and reactive to and even seeking rules from the outside world. Okay, the next aspect of the 21st century neuroscience was the importance of being social, the importance not necessarily of the amazing cognitive skills that human beings have, which had always been focused on early on in brain research, assuming that these were the skills we needed to understand in order to know why human beings were, at the top of the evolutionary tree. So we focused on language and creativity and science, etc. It now turns out that our ability to be social, or our particular portfolio of social behaviors, is as important to the survival of the human race as those cognitive skills. And that's reflected in the amount of, if you like, evolutionary space given to the front parts of our brain, which are associated with an understanding of social behaviors, not just cognitive skills. We know through various kind of tasks, and this is sort of area I'm involved in, that parts of the brain are associated with the emergence of a sense of self, sense of other people, sense of belonging. What group do you belong to? What are their characteristics? What group don't you belong to? And what are their characteristics? The social norms, how would you normally behave, or social scripts, if you like, social rules. So we have a really important part in the brain, which is determining that we're social, that we mix with other people, that we need to belong to groups of other people. And that is the secret to human success. And those parts of those aspects of behavior are not just a kind of semantic list. They're also parts of the brain which drive actions. So it's saying this is how you should behave, and these are the actions you should take in order to achieve this particular social skill. And these skills are driven, as all our behavior is, by pretty evolutionarily old parts of the brain, our emotions, positive and negative emotions. And just as any other experience is coded or tagged, if you like, in current social media terms, by being positive or negative, so are social behaviors. So whatever you do in the outside world, this will be something you should do, or this is something you shouldn't do. Similarly, and this is really where most of my work is focused, is there is a driving system in the brain, or if you like, I've characterized it here as a sort of combination of lights and railway points. There's a part of the brain which monitors the outcome of your behaviors, whether or not they were received positively or negatively, and acts very much more powerfully as a braking system than as an activating system. It will act as an inhibitor in any kinds of behavior which are going to lead to some kind of socially negative experience. And it's like an inner limiter in a lorry, if you like. It keeps you away from the mistakes that you might make and drives you towards the positive actions that you should make. Bearing in mind, of course, that the calibration, if you like, of this traffic light railway point system is determined very much by what's in the outside world. Okay, and all of these work together to determine the way in which we behave in society, and they start very early, as we'll come back to. Now, this is the key point with respect to my own work, if you like, and the idea that being social is a very powerful driver in the brain. And we have determined that socially driven behaviors are just as important determinants of behavior as what we used to think of just as fundamental survival mechanisms of fighting and fleeing and having sex, etc. So being social is very important. And one of the ways in which we've investigated this is using tasks rather unkindly devised to lower people's self-esteem or give them a negative experience, social experience, while they're lying in the scanner. So you can ask them to partake in a video game where, for example, just little cartoon figures playing a ball to each other, throwing a ball to each other, and your little cartoon figure emerges and they throw the ball to you and you all have a great time. And all of a sudden they stop throwing the ball to you and they reject you. And I've done this task and I know you're lying there and you think, I know this is a video game, but I'm really quite miffed by, I'm being rejected by my in-group. Similarly, you can ask people to muse on their self-identity, to see it being linked to negative characteristics, for example. You can ask on somebody's self-image, where do you think you are in the pecking order in your workplace or your family or your social group, etc. Or you can ask them to ponder on mistakes they've made and, how, was that really your fault? It probably was, wasn't it? You really should be careful not to do that kind of thing. So overall, we're activating the kind of effects of negative social behavior. And what's interesting with respect to describing or understanding how important a driver these processes are, is the fact that all of the areas, they're activating this inhibitory part of the brain very powerfully. The network of patterns of activation are very similar, in fact, in some cases indistinguishable from the same areas of the brain that are activated by real pain. So this is the idea that making some kind of social mistake, being rejected by your social group, not feeling belonging is a very powerfully negative emotion. And I think that's important that we remember that in understanding what's going on. I'm looking at the time. So moving on then, the key thing we have learned from all of these aspects, 21st century neuroscience findings, is that the world is a brain influencer. The world can change the brain in quite profound ways because the brain is seeking for rules in the outside world. So what goes on outside the brain is as important as what goes on inside as a driver of behavior. And the final bit of this jigsaw is an image from a tiny baby, the kind of measures we can take in our lab, my lab. We now know that this kind of social behavior, this social detecting, this understanding and following of social rules starts very early in life, from the moment of birth, in fact, if not before. Because babies used to be dismissed as almost subcortical beings, just reactive, really just noise-making, excreta-producing machines with very immature brains at birth, which gradually and fantastically quickly matured, and they acquired language and the ability to move, etc. But we now know that these tiny brains are like tiny social radar, primed from the moment of birth to really check out the outside world. Who's an important person out there? A face is a collection of images or a collection of shapes which is important to respond to, because it's more likely to be somebody who can help me or can give me food or calm me down. I need to understand different voices. Very, very small babies can distinguish their native language from other languages. So we know that these things start very early. Okay, so if the world is a brain influencer, this gets back at last to the topic we're talking about. Are boys and girls treated differently? Because it's clearly important that if there's something in the outside world that treats the owners of particular brains, whether or not we've labeled them as boys and girls, or as other people have said, left-handers or right-handers, etc., if there is information in the outside world which is going to change the experiences those brains those encounter, the attitudes that they encounter, we need to understand if the world is gendered, and therefore if it might change the brain in a particular way. And I could leave that blank, and I'm sure all of you could have a lovely time filling in for the sort of gender stereotypes which you find all around you in social media, on videos, in video games, in marketing, in toys, in clothes, etc. But I thought I'd just draw your attention to the fact that the 21st century codes the differences between boys and girls very profoundly, perhaps much more emphatically than it used to. So we get the classic cards that people give individuals when they're born, they have a child, and it's either, I have to be careful in case there's any card manufacturers listening out there, there's ghastly, it's a boy blue football cards, or it's a girl pink cards. And this is an image which characterizes a really horrible event which happens, it's only emerged in the 21st century, and that's gender reveal parties, where 20 weeks before an individual even arrives in the world, there's some kind of party devised where the parents will announce to their assembled gift-bearing, hopefully family and friends, that they're having either a boy or a girl. All the parents themselves discover at the party, and the party is themed characteristically in pink and blue. And what I've described as the pink and blue tsunami is I think very much a symbol of how much 21st century society distinguishes between boys and girls. So very early on, there are rules out there to be governed, to be gathered by these tiny junior detectives, which are baby brains, to say boys and girls are different, they're treated differently. The other thing that's important, and we'll come back to this in the closing stages, is that also has implications for the experiences that children have. And this is very much focused on toys. And this is a whole talk in itself, if you like, about how important toys are in early years, in children who have developing brains, who are learning skills, who are learning rules, who are learning the rules of gender society, who plays with what kind of toys, what does that signal? If you're a superhero who plays with amazing construction toys, you must be different from somebody who likes to be a princess and play with dolls. They might not at this stage have any value to it. They are very clear that there is a marked distinction. It's also the case that this carries on into education. And I was part of a BBC programme, part of a two-part documentary, which looked at gender stereotyping in the classroom by going into a classroom of 7-year-olds, looking at how much evidence there was of gender stereotyping in the very environment. You know, boys had a blue cupboard in which they hung their coats, and girls had a pink cupboard in which they hung their coats. Nobody could remember why, but there were just these two cupboards. And again, it's not as though, you know, if you hang your coat in a pink cupboard, it's going to do profound things to your brain, but it is part of a kind of ongoing signal that there is some kind of difference. And what was interesting, actually, this took part over 6 weeks. Somewhat alarmingly, at the beginning, there was tests of self-esteem in these 7-year-olds in these classroom, and what they might think they might be when they grew up. And by 7, they already had very clearly gendered views of what they could do. Girls thought being a boy might be fun because you could get to grow up to be president, but as they were a girl, they couldn't. Girls were very low in self-esteem. They were asked to rate themselves in how they would do on a particular task, and they were down in the, you know, on a scale of 1 to 10, and they were down in the kind of 3s and 4s, whereas the boys were up, you know, 9, 10, 11 if you gave me a chance. So they were, you know, really confident by then, and there was a whole load of examples. Interestingly, the differences that the team made over 6 weeks did have quite marked differences. And it did show that if you like, catch people early on, you can make a particular difference. But for me, the sobering finding was how stereotyped this very early exposure of children in education is. And the other aspect is really the world around us. I mentioned right at the beginning that the world is full of gender gaps. And Particularly adolescence is another phase when brains are very plastic. They are also rule gathering because they're gathering different rules about not being a member of a family or a son or a daughter. They're establishing themselves as an individual. So they look into the outside world. What do people like me do? And if that world is full of gender gaps, and it's quite clear from the kind of work that the World Health Organization does, that the world is still full of gender gaps. So bearing in mind that we're gathering our rules from this outside world, it's important to remember. I'm going to move swiftly on. I think we started a bit later, but I thought, given my understanding of what most of the audience would be interested in, was just to show a particular case study in how understanding the way in which the world can gender the brain can actually have quite profound implications for what people decide to do with their lives, and how that feeds into the gender gap, and how there is this kind of self-fulfilling prophecy behind these gender gaps. And this is a gender gap I've referred to earlier about why so few women do science. And I won't go into the multitude of statistics to demonstrate how underrepresented women are in science, particularly as it's quite clear they are capable. And I would make that as a statement. There are plenty of statistics to back that up. Women choose, for some reason, not to do science or not to stay in science. And this has been nicely characterized as women going into science, going into an organization where there is a glass obstacle course, where there are obstacles in your way which you're not aware of, which the culture itself may not be aware of, which make your journey to success in science quite hard. So it's just to draw conclusions about the fact that right from early on, there is an idea that girls don't do science. A lovely t-shirt here, I'm too pretty to do math. There's studies demonstrating that 6-year-old girls don't believe that they will only play with toys. They won't play with toys for really, really clever people because they're a girl and girls aren't really, really clever. 9-year-old girls saying that maths is a boy thing. So they're a girl, they're unlikely to grow up to do something with maths, even though their performance levels are better and are the same, in some cases better. So early on, we have a view that there is a particular type of person who does science. This is also associated with the experiences I mentioned earlier, the kind of toys that people play with. It's well known that in science, the ability, what we call the spatial ability, which is characterized here by a particular task called the mental rotation task, your ability to manipulate abstract shapes, if you like, or to understand the relationships between shapes in mathematics and physics, at a theoretical level or at a practical level with respect to architecture and engineering, that is identified as a characteristically male skill. And it is supposedly very robust, lots and lots of tasks like this, demonstrating that on average, men do better than women at these kind of tasks. But it's been demonstrated that if you don't just ask your participants if they're male or female, you also ask them about their spatial training opportunities, whether or not they played, what kind of toys they played with as a child, what kind of sports they play, what kind of hobbies they have, what kind of occupation they have if they're adults. And it's shown that if you then interrogate your data with this kind of spatial training score, that sex differences disappear, that women who've had lots of spatial training experiences for whatever reason do just as well as men on these kind of tasks. So the kind of experiences we have, as we know from understanding our plastic brain, could well be driving the brain in different directions. And it's been shown that this spatial skill is a core skill in science. And therefore, if you haven't, or your brain hasn't been trained in the right way, then maybe this could be the basis of a lot of the skill lack that women apparently have. And I just draw your attention to here to the fact that this is a kind of pattern of Lego, of construction toys, characteristically played by boys, which is very similar to the kind of mental rotation, spatial manipulation tasks that you need. I wouldn't deny that women, sometimes girls, sometimes are encouraged to do construction type tasks. But I just draw your attention here to the fact that we have this STEM Barbie, or Barbie the engineer, who is dressed in a somewhat stereotypical pattern. And the fact that STEM Barbie the engineer, can make a pink washing machine or a pink jewelry carousel. So I leave that with you as a kind of idea about, are we still, really on the right track with respect to encouraging girls? There's also the idea that the attitudes that people encounter will change their brains. And this rogues gallery here is a statement of 21st century males publicly announcing, for various reasons, that women weren't suited to do science. For example, James Damore, who wrote a memo to Google, effectively saying they were wasting their time trying to encourage more women into Google, because effectively men and women differ in part due to biological causes, but effectively, essentially, women didn't have what it took to be a Google engineer, and therefore not to waste one's time. So if you've got that as the attitude in, say, you're interested in joining a particular institute, and we know that will affect the brain, that's something to bear in mind. And finally, there is the idea that actually once you get into science, having got through, the idea that you're not suited for it, or you haven't given the right training, or people don't think you should do it, if you actually get in there, there is quite a profound bias in terms of the routes to success and award and recognition via the kind of grants you get and how often you're cited in papers, and the kind of acknowledgement of your contribution to research. And there is another whole area that one can talk about. So this is just to say, when we're talking about a gendered world making a gendered brain, this is something we need to bear in mind in terms of understanding that. And I'm just finishing here to say the take-home message, hopefully, that you realised is that a gendered world makes a gendered brain. It's a nice essentialist pathway which said that, sex is the primary driver of these kind of gaps because it produces different kinds of brains which will give you different roles in society. That is something that we really need to question and that we need to understand in understanding. So just to finish with the book, that's to say that this world will change. We have seen lots and lots of evidence that all the kind of aspects of attitudes and experiences are gendered within our world, and this could well be the basis of our gendered brain. And as I say, just a final plug of the book. So this is the book in English and this is the book in Spanish. Thank you very much. That brings us to 4 o'clock, and I think we started a bit later, so hopefully I haven't run on too long. I will stop sharing my screen now.
Muchas gracias, Gina.
Thank you, Gina.
Thank you. Okay. Apologies for the additional script, which for some reason has got attached to a slide. Must have been very confusing.
También quiero pedir disculpas a las personas.
I would like to apologize to the audience. At some points, Gina's microphone did not work all that well, and so the translation could not follow everything at some points. Maybe the signal wasn't that good. Anyway, I think we're doing fine with time.
There should be a kind of help message which comes up at some point.
No queríamos interrumpir.
We did not want to interrupt you, Gina. Yes, we do have questions. Question number 1. What happens with individuals, with people who feel they are born in the wrong bodies, with a sex they don't relate to?
That's a very important question, and one that I have been asked a lot. I think if we go back to the idea very early on that sex equaled gender, sex caused gender. So there appeared to be an unbreakable link between the body you were born into, which was genotypically determined, and the identity that you had, who you felt you were, who you associated with, your in-group, if you like. And it was assumed that one caused the other. And we know that has not always been the case. There has always been evidence of a disconnect for some people who have a female body and felt that they were more like a male, or the other way around. And some people will talk about being born in the wrong body, but they will also say, I have a female brain in a male body, or a male brain in a female body. The trouble is, if we now acknowledge, as we should, that there's no such thing as a female brain or a male brain, that makes that particular argument quite difficult to sustain. I think in a positive way, because I think it means that if your biology with respect to your identity or feeling of who you belong to is irrelevant, then you're free to be whatever gender you like. And you don't need to change your biology to be that gender. And I think that's important if that's part of the issue that individuals have. There are separate issues, and I think they can be separate, where people suffer from body dysmorphia and they actually dislike the body they have or parts of the body they have for particular reasons. But I think the issue of gender, and certainly in the 21st century, it is much more evident that gender isn't a simple binary category. And I have to say that, you know, if I was going to give a biology talk, sex isn't as binary as we used to think it was either, which is important to remember. So I think the book and the argument I'm making is very relevant to that particular issue. I'm not saying it offers solutions, but hopefully it offers understanding.
Gracias, Gina.
Thank you, Gina. Okay, we translated your question, but we have another question. What do you think, or what does science think about schools for girls and for boys only?
Yes. Oh, that's another very good question. Certainly with respect to science, there is a suggestion that successful female scientists have more often been to single-sex schools. And that is claimed as proof, if you like, that teaching girls separately from boys, it can be a good thing with respect to science. I think it's very much entangled with the whole issue of the fact that our brain is social as well. And there was some interesting work done on dropout rates from science. So there's, as people will know, there's a kind of chain, you know, we can get people in to do science, but there's a whole long pipeline in terms of different stages of the scientific employment, scientific research, scientific education, etc., through to, you know, the upper stages. And women drop out at those stages much more frequently. Sometimes they talk about work-life balances, etc. But one of the issues is also associated with the misogyny, to be honest, that women had encountered in science. And women who'd been to single-sex schools found this much more distressing and disturbing than girls who'd been to mixed-sex schools. You know, it's an unfortunate testament that the girls in the mixed-sex schools had probably encountered and been trained, if you like, to deal more with misogyny. But I think it's important to realize that success isn't just to do with having the right set of cognitive skills. It's to do with this very powerful driver we have to be social. And we know that loss of self-esteem is associated with behavioral changes, such as withdrawal or disengagement, or you know, dropout, or it's called academic, sometimes a self-silencing. So the kind of social framework is important to the cognitive framework. So single-sex schools, I don't think necessarily apply the right kind of social training. So as you're probably gathering, I don't think single-sex schools are a very good idea. I think what you need to do is sort out the stereotyping within mixed-sex schools to, you know, ideally to stop it early on, so it doesn't matter that it's a mixed-sex school, because you're all thinking about each other as individuals.
Gracias, Gina.
Thank you, Gina. Can you hear me?
I can hear you. Yeah, I can see lots of questions, but of course, some of them are in English and some of them are in Spanish, so I better leave it to you.
Vale. También otra pregunta es un poco en la misma línea. Si
another question. Yes, another question. The book men are from Mars or women are from Venus. You know, these books are, do they just want to be bestsellers, you know, and use science the way they best fit them?
Yes, I did. Part of this campaign started with me talking about neurotrash, which is the idea that when brain imaging arrived at the end of the last century, beginning of the century, those images were so compelling. They also unleashed a tide of what I call self-help neurotrash books, where people who were relationship counselors or just populist science commentators who wanted to talk about the differences between males and females hijacked a lot of those images, which did show differences, because there was work where you could show differences, although the early ones, based on very small numbers. Some of those images, for example, that women deal with language on both sides of the brain and then on one side of the brain, that's a very early image, which was actually completely wrong, but it's become very, has a lot of stickability. People will keep quoting it to you. So the whole men are from Mars, women are from Venus trope, if you like, I think characterizes really nicely what's in the outside world. And I could just have stuck that book in the space in the outside world, because it informs what a lot of people believe, because everybody is invested in understanding the differences in their brain and their gender, and are very interested in it, understandably. So if you've got somebody who explains in very accessible language that males and females are different, so different they might come from different planets, then of course you think differently about yourself and will behave differently. Other people will treat you differently, parents, for example, dealing with sons and daughters. So we get into this self-fulfilling prophecy, which for me is what gender stereotypes are about. We kind of get the brains we believe we have, which is why it's quite difficult sometimes to unpack. If you're dealing with a gender gap, what are you dealing with? Are you dealing with a biological variable, or are you dealing with the end product of a long social training, biased social training of a particular kind?
Muchas gracias, Gina. Gracias por...
Thank you, Gina, for your very interesting answers, and thank you to the audience too. There are more questions, but yes, to finish with, one more question, which is a bit of a summary and a comment. I'll read it out. Then the context creates differences, but brains don't have biological differences. Am I right, Gina?
That's the do you think it's all culture and no biology accusation sometimes that gets leveled at the book. And it's very much not the type of message, the single message that I wanted to convey. I think I was trying to rebalance the argument that we're just looking at biology, irrespective of what goes on around us. As a neuroscientist, I believe that our brains are the core of everything. I would say that part of the belief system is that brains are different, and actually neuroscientists should put their hands up and say we can't find any differences. But I think actually our focus on structures, which if you like goes right back to the weighing the brain with birdseed, we still focus a lot on measuring tiny bits of structures, using wonderful developments in brain imaging techniques to still look at structures. I think we're looking in the wrong place. I think we shouldn't be staring at the structures. We should be, if you like, listening to the language of the brain. And I think then we might start to see the fact there are sex-related differences in the brain, because I do believe they're there. I mean, clearly they're there with respect to hormone receptors, for example, with respect to the reproductive process. But I think there are other processes. But the problem we have, particularly with our plastic brain, is that we might find differences, but when we can't be sure where they necessarily started or came from. So I could, if I've got a lot of people coming through my lab, I'm not suggesting, you know, maybe they're all taxi drivers or something, but they will bring a lot of different experiences. Maybe if I see them at the beginning of doing their degree and at the end of their degree, their brains will be different because they will have had lots of different experiences. Their brains might not be different because they're females or they're males. Their brains might be different because they've had 3 years of partying hard or 3 years of studying hard. And so I think I would definitely say this is still biology, but what we need to realize is that when we talk about the brain, almost as if it's separate from society, because it goes back to the argument, it's either nature or nurture. I think what we're looking at is the fact that the two are so entangled that we should be careful in attributing primary explanatory power to either the brain or behavior. And I think that's the trouble with some of the initiatives that people quite rightly try and follow to increase diversity. They think, oh, it's something to do, women are all different, so we need to bring more women in to make our workforce diverse. But actually that in itself is can be problematic. You could say, let's have a look at how individuals are different. But while we're still focused on male and female, because it's a nice, easy category, obviously visible to everybody, but I think it's mistaken. So it's not all culture and all biology. I think our biology makes us more or less susceptible to different parts of culture. I'm sitting on the fence, sorry.
Muchas gracias, Gina. Y ahora sí nos acercamos.
Thank you, Gina. Okay, drawing to a close now. We'd like to say thank you to Gina. Special thanks for your work in such an innovative field, taking into account both the brain and gender stereotypes in the outer world. And from ADItech, we would like to say thank you to all of you, our audience in Spain and abroad too. Thank you for being curious about science. Thank you for coming to us today. So I hope to see you soon.
Could I just add that if anybody wants to email me, I put my email address on the first slide. So if anybody, I have to confess my Spanish probably wouldn't cope too well, but I could have a go. So if anybody's got questions, then feel free to email me.
Muchas gracias.
Thank you. Thank you. See you.
Thank you. Okay. Bye for now.